So we are here at Red Hat Summit, and we have with us Dr. Grant, not from Jurassic Park, different Dr. Grant. So Dr. Grant, can you please quickly tell us, about yourself and what you're doing at Red Hat Summit?
I'm at Red Hat Summit because we wanted to improve how we do image analysis in medicine. And so we wanted to go to the plumbers, so to speak, of the software industry that can give us security, reliability, reproducibility, and interface with open clouds, such as a mass open cloud, so we can ramp up the speed at which we do data analysis in medicine.
So what kind of data analysis do you do in medicine? Why do you need medicine is just,
Oh, medicine, the amount of data coming in medicine is exploding. Mm-hmm. We generate terabytes of data from our scanners. So even when I'm reading, say, on a clinical day, I would look at 100,000 images, up to 100,000 images, and that's just getting worse as the speed of our sequences are getting faster and faster. So there's a huge amount of data that comes through, say, for me as a radiologist. On top of that, now I have genetic databases I need to look into, the electronic record I have to look into. Then there is additional information from, if it's a patient in the ICU, for example, there's data coming off of vital monitors, heart rate, blood pressure, oxygen saturation, all this data. If you have a neurological disorder, you might have EEG data.
Right.
So all of that is going into hospital databases that are separated from each other. Mm-hmm. So what we want to do is have a platform where we break down those silos and have all that data available to do big data analysis on.
Right.
And to hopefully, for example, one thing we're doing with some of the new optical devices that we have, we can pick up cerebral blood flow, but we need to run an analysis simulation or data analysis to get the results back. So instead of taking minutes or hours to do that, we can now port it through CRIS to the MOC backend and have it in seconds. So in real time, I can provide these novel new data sets, and I can ramp it up a notch moving forward because, say, optical devices, I need to know the brain anatomy. Mm-hmm. So I can include, say, the brain anatomy in a Monte Carlo simulation in that in real time moving forward. Or I can create a database of all the images of a certain type of disorder, and as soon as a patient comes in, it can do a rapid comparison to that huge database and tell me, well, which one looks most like this and what was the best treatment for that person, and if I include other electronic record and so on, can they better help me manage each individual patient.
Right. You mentioned data analysis. Now, machine learning is kind of becoming very, very popular, and it's also kind of democratized by open source and a lot of frameworks. Mm-hmm. So do you also use some kind of deep learning and machine learning technologies?
Yes, we're very interested in machine learning and deep learning because we have, again, lots of data sets, so we want to do not only hypothesis-based analysis of the data, but also use machine learning and deep learning to pull out features or extract features that I wouldn't necessarily anticipate. Mm-hmm. Let's say the one thing we do different on the medical side is we want to go back and then biologically interpret what the features are that help distinguish, say, different disease categories or different outcomes. Because if I can't understand the biological motivation, it may be something that is just driven from the data set or something that is not biologically relevant. So we like to have that additional loop closed as well.
And what role does open source play there in all of this?
Mm-hmm. What we believe is all our code is on GitHub. We believe that we should come together as a community to share these data sets, not only across different types of data sets within a hospital, but also we have to work together, different institutions together to solve big problems. Mm-hmm. So for example, whatever disorder you choose, there's only few that occur at any one hospital. So to really solve the problems, we have to bring in multiple hospitals. And ideally, we're hoping to partner with the developing world because things happen differently in the developing world. They have different genetics. There's a lot of things different environments. So there's a lot of things we can learn from, say, how a disease is presented in a developing country versus, say, in the U.S. Mm-hmm.
But when you, as a medical, community versus then you're dealing with the software development community.
Mm-hmm.
So do you have your own developers, or do you partner with?
We partner with Boston University and the Mass Open Cloud team. So Ataturk works with our technical lead, Rodolphe Pinard. Mm-hmm. So we've got feet on the ground, people working together, and then there is Dan from Red Hat. So the three of them are sort of the core front end that work together. And it's actually been, I think, a really good learning experience for our team to learn how to participate in an open software community. We've always posted our data to GitHub, but actually learning how to share in that way, it has been a very good experience. And I think, frankly, it's actually how we practice medicine. You know, as physicians, we talk, we collaborate, but now let's make it with our data and how we analyze our data, because very little is reproducible in research or in medical research. So can we create an infrastructure where we build on other people's accomplishments, sharing data, but in a platform that it's reproducible?
Right. The way I look at, everything is kind of becoming software driven, and the technology and software is playing a very big role. As part of medical community, do you think that there should be a new branch or new disciple where it's like medical engineers or something like medical software? I don't know. Because
yeah. Well, we do. It is merged. There are informatics, I guess, is the one I would say is closest to that. Traditionally, they've dealt with the genetics, the hospital record, almost everything but imaging. So we're also working with the informatics team, both at Harvard and in our institution, to try to cross that divide and bring imaging into that portfolio as well too. So there's a lot of, I would say there is a new field emerging between those, but it's also, I'd say it's across the board in medicine, because no matter what we do, a physician is never enough. So if I'm using, say, or developing innovative optical devices, I need the optical engineers. When I'm doing MR scans, I need the MR physicists. When we're doing data analysis, we need people with the informatics background and the coding skills, and also we have to build the platforms. Just like I have to build robust MR systems, I need a robust platform that we can scale up, scale down, that's cost effective and secure, but can give me data back as in the speed I need it, and ramp it as needed.
Yeah, because if you look at traditional ITs, there used to be silos, So
Yes.
here also, we have silos of doctors, or medical practitioners versus software developers. So it's still merging.
Yeah, and getting people to talk together, because it is. I think everybody is a little intimidated when they go outside of their own domain of expertise. So that's part of what actually in my group, what I do is I take the experts and I embed them in the hospital into different clinical services, so they learn to talk together. And we've had a lot of success with that model.
Right. You said that you're also kind of, expanding into the emerging markets or developing countries.
Yeah.
So what are the countries, that you're kind of targeting, and why?
Yeah, we're interested in China. We've been talking to a lot of people in China. The reason is, particularly as a radiologist, they don't have enough radiologists to read the data they generate. So is there a better way to screen patients or to filter the data? So we're working on algorithms right now. Quantrix should come through to help detect and determine what type of brain tumor, say, a person has. So if we could do that first line, you could walk into a clinic and get your MR right away. The data gets sent to some through our platform, for example, to a large cloud that does an analysis, say normal, abnormal, that does a lot of justice. Or can we differentiate different types of disorders and say, well, this one can be dealt with by the local community, this one needs to be flown to a very experienced tertiary center. So that's where we're interested in working with the community from China. And then we're working with teams from Malaysia and South Africa as well too, which suffer from the same thing in that they don't have many experts. So in areas particularly that I deal in, which are newborns or fetuses, not many people have that expertise. So it's felt more acutely in those spaces, but I think it generalizes to many rare and complex disorders. So when we have institutions such as Boston Children's, we see all the most complicated things. We may only see one or two, so most people will never in their lifetime see something. So when a rare disorder pops up, it's hard for them to be able to flag it. And some of these need treatment immediately to prevent progression. So we think, help with some of the, at least the imaging informatics part, but moving on to adding additional information as well too from the electronic health record and blood work. Any kind of data we can get can be incorporated into these models moving forward.
Last year I met a medical practitioner from Kenya, and she said that what happened in most of the time is tuberculosis is a big problem there. In smaller villages, people have to go to big cities, and then and then the medical record is sent to a bigger hospital for analysis, and then they have to go to there for scanning. And there's so much process that it discourages people, because take like in those African countries, sometimes it's hard to even travel, commute. So it discourages them to go to the hospitals and doctors because it takes so much. So have you kind of looked at those challenges or problems also, and you think that it can be?
Yeah, and there are some devices that we can take to that are portable to these systems. It depends on the power supply and many other factors as to what is feasible.
Right.
But I think a lot of people are wondering about a model where you deploy small clinics of data gathering, maybe not a physician post there because there's just not the resources or the economy to do it, but places that can gather data that then can be sent to a centralized site for interpretation. And there's video conferencing that also helps with a lot of the patient interaction. So I think that's where we're moving to in the future.
Okay. Now let's just switch gear from medical and just talk about how close. I mean, you did mention that you work with Dan from Red Hat. What kind of collaboration is there between Red Hat
and with us? So my team actually, Rudolf Pinar from my team spends a couple days a week actually at Red Hat. So working together with that team, we've run actually, I'm going to forget the name of it now.
So he's getting 2 salaries? They're getting 2 from Red Hat?
No, not from me. Actually, this is actually really interesting. I pay my guys, BU pays their guys, and Red Hat pays their guys. So we all have time on the table, but no money is exchanging hands at this point. So we're all, which is actually means we're all really invested and believe in the project. Hopefully we're just discussing about how we can ramp it up and generate additional revenue from NIH or other vendors to try to move this forward with more resources. But right now we're all, it's nice to start small because we're creating a community that understands each other, because again, I think the BU and Red Hat teams understood each other more than we did because we're coming from the outside.
Right.
So we're now getting a good sense of that space. So I think we're at a point that starting to grow would be feasible. So I'm not the technical person. Rudolf can tell you about OpenStack, OpenShift, and how they're integrated into it.
Right.
For me, what they do is actually make it so I can actually not have to be a computer scientist or an engineer to analyze my data or interpret the data, which is how I deal with, say, MR imaging. Although I'm trained I have a master's in physics, I'm not an MR physicist, and I don't know how to build the machine, but I still can interpret the data that I get off of it. So I have to develop partnerships with those people that have that domain expertise. And that's, again, I think a model that we're all moving to. The world is too complicated and too big for any one brain to hold it all. So we all just admit that we don't know everything and work together to come up with better solutions.
I mean, I don't have to be an engineer to drive a car, right?
Yeah, exactly.
It should be as
exactly,
simple as that.
exactly.
Since you do work with the open source communities, and what the open source has done, it has kind of democratized a lot of in the software development. But do you think it can go beyond just software, and it can also democratize? I mean, you're also putting your data on GitHub and all, but it can democratize science or medical science, or how we treat. Have you?
I hope so. I hope so, because I think that the more we share data, we get to build on each other's accomplishments instead of competing. There's too many problems to solve in my mind to compete. So if you've done one part, why don't I do the next level above, or try this angle? And we're working on ways to actually give people access to more data, because I think different points of view bring different things to the table. People have traditionally been very protective. There's, of course, all these things we deal with very carefully in terms of patient privacy, but there's still ways to anonymize data and give everybody, or give at least vetted people access to compute at least on your data, even if they don't download it. So we can come up with ways to secure our data, but make it accessible to people who have good ideas. And ideally, pool resources from multiple institutions. And that's particularly a case with pediatric population and rare disorders. Like many pediatric disorders, there's never enough at any one hospital. So there's already a wave underfoot of multiple pediatric hospitals getting together to share data so we can better understand these less common disorders, which are devastating, but not any one of us have enough to really solve the problem.
Are there any efforts going on to bring it together?
Yeah, there's many efforts more in the public cloud to bring some data. I've not seen so much in the imaging space, more in the genetics and some of the electronic healthcare record.
Okay, and I mean, this is all looks good, but at the same time, there may be some challenges also that you see, some roadblocks. What are those?
And I think the biggest roadblocks is to make sure that we maintain patient privacy or have ways to move forward in this era without compromising that. And that's part of the reason we like the concept of the mass open cloud. You don't want to give your data to just anybody, especially if it could be a company that could fold in another year, and then who's going to have access to it. So I think what is something that resonates more with me and with a lot of people that I talk to in the medical field is as we start to grow our own systems, because as our data keeps getting larger and we generate it faster, we can't really manage it within a hospital system because that's not our expertise.
Right.
We need to partner with groups such as the Mass Open Cloud, where we can build consortiums of trusted people like Harvard, MIT, MGH, Brigham and Women's, and Beth Israel. We're all actually in Boston, so there's a feasibility of having consortiums that could oversee data and data security, and we could at least between each other share some of the analysis and some of the data in many applications.
You mentioned privacy, but there are a lot of regulations also, right?
HIPAA. Well, HIPAA is sort of the main privacy regulation. The other thing is FDA regulations around any data analysis. So when we move towards new data analysis to really use it in patient care, there needs to be some kind of approval process, and often even some software needs to be FDA approved for us to use it in standard clinical practice. So we need to navigate ideally to a world where we can move faster than the FDA can approve. For example, what we do at Children's Hospital, many things we do that are cutting edge have not yet made it through the FDA process. So we get informed consent from people so they understand that they're coming to a place where we're using cutting edge technology and treatments. So there's that push and pull between wanting to get that stamp of approval from FDA, but yet wanting to provide the best patient care that exists at this point in time. And those are often different things. So trying to navigate that effectively, I think, is a challenge as well too.
And some of these technologies or procedures are also very expensive. So how do you kind of work towards either funding all this research and the work you're doing? Or
Right. Well, these shared cloud infrastructures actually do address some of the cost issues, because if we can only use a computer we need at the time we need it, use a scalability factor, we can reduce the amount we need to spend, especially if it's done in a cloud where we're allowed to do our own compute on our data. Some clouds you put your data in there and it costs you every time you compute on it. So we have to be careful what environment we're setting up so we don't limit what we can do because of the cost of the compute. So hopefully by using open clouds where we can scale up and scale down, it becomes a financially viable option. And the goal of, I think, the bigger institutions right now is to try everything and come up with the solutions that we think are the best. So we're going to be trying things that fail. That's what innovation is about. And then when we get to something that we think works, then that's passed on to the rest of the community. So I don't think every single site is going to be wanting to do the full depth and breadth of what we're doing. We're sort of the vetting site to try to come up with some of the better solutions with participation ideally from other communities. So I think it's really important that we don't just say, well, it's a Boston thing only. It'd be nice when you actually have a woman coming to visit from Malaysia, and she's going to have great ideas. Maybe we can incorporate into what we test. Everybody comes at it from a different need or a different background. So just creating an environment or community people can come to and make suggestions and participate is what we're hoping to do, and that will cost more, but hopefully in the long run we'll get a smaller set of tools that everybody can use in a cost-effective way.
So you mentioned the Doctor for Practitioner from Malaysia, and you kind of touched upon something which is close to my heart, which is diversity. So what kind of diversity, because as you said, it's a big topic, it's very complicated, what it means to you, and how is the medical community kind of dealing with it?
Yeah, I think diversity is a really important issue to us. It's not only, there's male, female, different cultures and different backgrounds, and medicine, we understand more and more how genetics, culture, and environment all influence disease. So this is why actually I'm really excited to work with people from different countries, because if I see some disease process evolves differently in one community than here, we're talking to people from Tibet and they're saying how they are very healthy and they don't have as big a problem, say, with tumors. So can we take different communities and compare them and try to understand what's different either about the genetics, the gene expression, the environment to help inform how to better treat other communities, or to look at, again, how medicines are used. So there's a lot of comparisons we can do by comparing different communities that have, again, different even within Boston, there's different hospitals that do different things. So there's a lot to be learned by compare and contrast if we put all our data on the table so we can look at each other and how we're practicing and learn from each other versus protect things.
What else is your biggest concern in this? As you already talked about, silos in the tech industry versus silos. So can you talk about that? What is your?
Yeah, and my goal is that we're going to have teams that actually learn how to talk across these expertise because. And I think there's a big role of having the software developers being exposed to what are the clinical questions that we have a dialogue. Because I think when people work in a vacuum, assumptions are made that are not necessarily accurate. And same thing happens, I think, in the medical community. There may be assumptions made about what can be done with the data analysis stream, and you need to get those two groups together to have discussions to really move things forward in a way that is relevant to how we manage patients. And sometimes it's the software team opening a clinician's mind about how data can be analyzed in a way they never thought possible. So I think it goes both ways.
Awesome. Have you seen Black Mirror?
No, I haven't.
Yeah, okay, then I cannot talk about that, but that kind of creates a very, very freaky world that technology and medical science work together to take control of our lives.
Yep.
But, so should we be worried about technology, or should we be happy and kind of?
Yeah, people, particularly in radiology, are often afraid of artificial intelligence because some people say it's going to, I know there's quotes from famous people out there saying that we're going to lose our jobs as radiologists. From my point of view, I would rather spend less time looking at the images and more time thinking about them. So if AI and machine learning and deep learning helps to filter the data to give me relevant data, helps bring other relevant information, and my job is to synthesize and make judgments, I'd be rather doing that than looking at like 100,000 images a day. So I think AI has a big place to a big role to play in focusing our attention and allowing us to think more.
Right.
And I think we shouldn't be afraid of that. And then the other thing I love about machine learning, deep learning is it can take what, I make judgments on an image, for example, based on this gestalt I've built over a decade or two of practice.
Exactly.
Which is all biased by where I've practiced and who my teachers were. Whereas we could create deep learning algorithms to create models of normal, and that's some of the things we're working on, our normal atlases. So it's not based on my learning or gestalt, it's based on a machine learning or deep learning telling me what is the range of normal in each different age group or in different adults. And same thing with disease presentations. I have in my mind, and people put in textbooks, little line diagrams about where the brain is affected with different diseases. That's based on a pair of eyes and a memory, not on putting together 100 data sets and doing a probability map. Right. So I think there's a lot that we can do with imaging moving forward to make our science more accurate and less based on personal gestalt memory and more informed by real data.
Right. Yeah. People get worried about it, but it's just kind of another tool.
Yeah. It's like if you were a compter and you were doing long math and you got a calculator, you would put them out of business. But it actually elevated us to a different level of thinking. Yeah. So I sort of see this as that. I have to now think deeper and think more because it's not just looking at pictures. It's integrating data. And I think that's something that I look forward to doing because I think that's how we move science forward and move medicine forward.
And that's kind of a story of humanity also. The moment wheel was invented, it put all those people out of job who were carrying locks on their backs. But because now you can put 4 wheels, but it also created Uber and taxis and cars and aeroplanes and everything. So that same thing will happen with technology also. And I don't think that human body should be used as a machine. It should be used as a tool. To create something new, better, or come up with.
And to have an idea how to link things together, because I think humans, especially when we deal with like a disease in medicine, you get instincts about what is a good thing to do, and that a computer doesn't necessarily get. It may be looking at the wrong pixels.
Right.
So this is where we can actually guide where we think the right directions are to go, and in some cases we may want to ignore some data because something else is more relevant.
Right.
So there's a lot of judgment still because it's still we don't understand the human body deeply in many ways. So there's still a lot of judgment and experience that needs to be applied to these tools at this point in time.
Awesome. I think we had some great broad discussion of broad topics, and thanks for coming over.
Oh, thanks so much for interviewing me. It's nice to meet you.
Thank you.